Well, good morning, everyone. Today you are going to be working on doing some graphing with the notes from yesterday. So I would like everyone to open up their notes packets and open up to problem 1 from yesterday. We are going to copy the table. Well, I copied the table next to the graph. You probably don't need to because it's likely on the same page. But we are going to graph the points and find out if this is a linear function or not. Now, before we can graph the points, we need to develop a scale for our x and y axis. Notice the independent variable, the x, is the figure number, and that is on the x-axis, and then the number of squares is the dependent variable, and it is on our y-axis. Now, the x-axis here, I only have to go up to the number 3. So what I think I am going to do is I'm going to have a number after every 5 lines. That way we're going to use up most of our space here. So after 5 lines, I'm going to put my number 1. After another 5 lines, I'll put the number 2. And then after another 5, I'll put the number 3. And so the reason why I'm doing that is so I can use up most of my graph. Now, the y values, I have to go from 1 to 13. If I consider each square to be 1, I have enough space here because this is 20 tall. So I'll end up using up a little bit more than half of my space, but it's not enough space to count up by 2's because then I would need 26 lines. I only have 20. So I'm only going to count up by 1's. Now I want you to pay close attention to how I have the my number line set up here. Again, I went every 5 lines and then I've placed a number on the x-axis. If there's 5 lines between 0 and 1, there needs to be 5 lines between 1 and 2 as well. Okay, notice these are equally spaced. Also notice I put a little line here indicating that this right here, this line, this vertical line, is where 1 is. Okay, I expect you're going to do the same. I expect that the distance between any two numbers on your number lines is going to be equivalent. So if I'm counting, each line is representing 1. And then notice I've only numbered every other line so that I don't see so many numbers. The point of it is that you want to be able to read your graph. If you have too many numbers in here, you won't be able to read it. So you need to make sure that you make it readable. I like to skip every other line and label every other line. That way it doesn't get to be too much. Now we actually go through and we plot our points. So the coordinate 0, 1 is you go over nothing and up 1. This is your horizontal movement. The x is. Okay, so left or right, nothing, and up or down, nothing, or up or down, 1 for the y. Okay, y is up and down, x is horizontal. So to find this coordinate, you have to go over to the right 1, positive 1, and then up 5, and there's your point. Notice even though 5 is not labeled, it is here between 4 and 6. 2, 9. Go over 2 and up 9, and 3, 13. So this is what our graph looks like for this particular problem. Now remember, this was for the number of squares shown in the figure. So the question I'm going to ask you is, can I connect the points on my graph? And the answer to that is no. Because if you look back at that picture, do you ever have a instead of having step 0 here, or figure 0, could I have figure 1/2? Is it possible? Could I have figure 1.25? No. It is figure 0, 1, 2. There's nothing in between. So therefore, you have to just leave these as points. Yes, it's a linear function, however, because the points make a line. However, you're not going to connect the dots because it doesn't make sense to. Okay? Whereas the next problem, the water problem, right? how many gallons of water are leaving a pool or in a car wash after the total number of minutes. So this is going to be very fluid. You know, after 10 seconds, you're going to still have lost some water. So you want to make sure that you connect the dots on this one. So what I've done is I've copied my table next to my graph. Notice I've labeled my x-axis is time in minutes. The y-axis is number of gallons of water. And notice also we only have to go from 0 to 3, so I've labeled my x-axis in the same manner that I have done for the other problem. Now, the y-axis is a little bit different because we're all the way up in the 400s, which I don't have enough space to count by ones if we have to go all the way up to 400, right? My graph is only 20 high. So what I'm going to need to do is maybe put a break in my graph, and I only use breaks in my graph when I can't represent all of the numbers from 0 all the way up to where I'm going to zoom in on my graph here. Okay, so maybe I start, my first number might be 400 because it's closer to what my gallons of water that I'm working with is going to be. So I'm going to start off with maybe 400, and maybe I put 400 right here. Okay, I'm not going to place a number on every single line like I said before, so I can skip a line, and then I'm going to choose to put the next number here. And again, and so on and so forth. I'm going to skip a line, put the next number here. Now, I don't have to go up by 1 each time. I can choose to go up by however much I want to. So I think I might start, since I have to go up to 440. If this is 400, 410 might be here, 420, 430, 440. That only uses up about half of my graph. I don't like that. I want to see more of my graph. So what I think I might do is if I put 400 here, I'm going to skip this line I just drew and put 410 right here. That might help me use up more space, because what we want to do is zoom in on the interesting part of the graph. Okay, so that's exactly what I did. I put my 400 here after the first 2 lines of the break here. Okay, this break in the graph is just indicating that I'm going from 0 all the way up to 400, like I've zoomed in on the top part of my graph. Okay, and so then notice I have everything evenly spaced. There is 4 lines in between each labeled line on my graph. Okay, and there's 5 lines in between each of these. I do expect when you're doing your problems that your number lines on your graphs are evenly spaced. And that you don't have, if there's 20 lines going up, I don't want to see 20 numbers here. That's not what I want to see. I want to see a nice and readable, just like this. Okay. Next we get to plot our points. So 0, 440 is going to be way up here, and because I'm going over nothing but up 440. The next one will be 428, which is going to be right below 430. Now notice this is 425 right here, so 428 is going to be somewhere up in here. Okay, so I have plotted all of the points. This is what your answer should look like. Now, what I do expect for you to do for the remaining part of the hour is to go through those homework problems from yesterday. Each of these homework problems, there was a part of the assignment that said graph it. Okay, there is graph paper available on the side table next to the door. You need to take a piece of graph paper. You only need one, because what you're going to do is fold it in half twice. Okay, so you have on one side 4 rectangles, and then on the other side you'll have another 4 rectangles. So there's enough space there for 8 problems. Convenient because you only have 7 homework problems that you have to graph. Okay, number 6 and 7, and then 9 through 12. So no, 9, 10, 11, 12, so that's only 6 questions, pardon me, 6 questions that you have to graph. Okay, so you should be able to do this on your own with this instruction. Please let me know if you have any questions at all. I will be back tomorrow. Again, you're going to graph for each one of these. Each problem gets its own graph. You need to choose an appropriate scale and put a break in your graph if you need to. For example, number 11, you'll probably need to put a break in your graph. Number 12, you'll probably want to put a break in your graph because otherwise you're not going to see much variation in these numbers. Okay? So again, if you have any questions, today all you're doing is graphing for the problems that you did yesterday in yesterday's homework. Okay, so same assignment, but today we are going to do the graphs. So I'm going to change this, do the graphs. Okie dokie. Have a good rest of your day, everyone.